All right, so using technology. Sometimes dividing out and rationalizing techniques don't work either. Okay, we can't use those to find non-algebraic functions. So sometimes we need even another way, and another way is just use our technology. So here, I want you to put this one in your calculator. To put it in your calculator, you only put the equation piece, okay? Don't worry about the limit part yet. We can see if we try direct substitution, what happens?
It turns out to 0.
Well, you got 1 over 0 as an exponent, right? So there's going to be something there that's not working because you can't have 1 divided by 0. So we need another way. So let's try using our calculator. So type that in your y equals. And we're going to first look at a table.
Y equals?
Yeah, go to your y equals, and we're going to look at its table. Now, when I look at my table, in the middle of my table, I want the number that it's approaching. So what number is my limit approaching? 0. Now remember, I need 3 numbers that are really, really close to 0 in both directions. So, how about negative 0.001? And I want even increments because I'm using my calculator. And I want it to create the table for me. I don't want to have to stress and plug things in. Because we did that in 12.1. And then using the same increments, and I would do the positive of those.
Wait, so how do you get to that?
How do you get to what?
How do you make your x's so small?
Oh, don't worry about that yet. I'm going to tell you in just a second how to put it in your calculator. Right now, we're just picking some numbers. All right, so to do this in our calculator now, guys, you got your equation already in y equals, correct? So go to, do you see your window button?
Yes.
Do you see above it, it says table set?
Yes.
So go to second window, and we want to set our table. Well, where do I want my table to start? No, look at, where do I want my table to start? What's the smallest number in my table? So negative 0.003. And the change in the table. How often do I want those numbers to change? What increments do I want? 0.001. So then go to your table after you get that typed in. So looking at your table, guys, I want you to write down all of those digits that it has beside those numbers that we picked, okay?
I don't have any digits there.
You don't have anything in your y equals then.
Oh, wait.
So you should have the first one should be 2.7224. If not, you made a typo. I want all the numbers that they have there. And there's a reason. Alright, so what I want you to do then is you're going to take remember the limit. Is that dealing with the x or the y values? The actual answer of our limit. It's my y values. So we're going to take the average of the y values to approximate the limit. So we're going to take the average of the y values to approximate the limit. So we come out with, I'm going to write it here at the bottom, I'm going to rewrite my problem. So the limit as x approaches 0 of 1 plus x raised to the 1 over x is going to be the average of these two y values. So how do you find an average?
Add it together and divide by 2.
Oh, now y'all got that, right?
Yep.
That's back from the good days in math, huh?
Yep. Gosh, on the SAT it's like find the mean, find the mode, find the average, and I'm like, and so I'll mix them together.
All right. Now you can also, guys, ladies, you can also use a graph to help solve this. Now, I'm not the biggest fan of the graph because using your graph is like, when have you zoomed in enough on that point? I don't know. So go ahead and hit graph on your calculator. You already have the equation in there. And so sketch that. Now, we can't see what's happening at the 0. It looks like there's it looks like it continues. We know that there's nothing there, right?
Right.
But I want to know what is happening here. What y value is this getting really, really, really close to? Well, to do this, we're going to go to Zoom, and we're going to choose Zoom in.
How many times is one?
Now, before you hit enter to tell it to do it, once you choose the zoom in, put your cursor on what looks like to be that y-intercept there where x is 0, okay? And then hit zoom in.
Where x is 0?
Yes, where x is 0. So up there where I kind of circled there. So zoom in. Once you do that, okay, keep zooming in. Keep moving that cursor to where it's going to touch it because sometimes you're off.
I see the hole.
And zoom in several times. The thing is how many is enough? I don't know. So get in. I went into the point where I found it was like negative 8.311 e to the negative 4. All right, so get to the point where we have like an e to the negative 4 and stop. Wait a minute. You're never going to get that. I'm sorry.
Yeah.
So, sorry. I forgot to say something. So you're going to zoom in a couple times, okay? Once you get to a point you think maybe I'm enough, hit the trace button. I forgot to say, you got to hit trace and then arrow to the left. And I'm going to say enough is when I get some number, some negative, some number, and then e to the like negative 4. If you get smaller, that's great.
What is trace? Oh, I got 4.15. Is that not enough?
All right, keep going. Nope. So go back to zoom.
Zoom.
I want to see that e to the negative something there.
I'm really good.
All right, so what I found while y'all are playing,
9.4697 e to the negative 4.
that'll work. We're all going to end up with a little bit different number, okay? Well, not all, but that doesn't mean they're all going to be exactly the same. So this is a number I found on mine.
There is a hole.
Mhm.
Where do you? That's it. That's all. Yeah, I don't get how you're finding those really small numbers. I don't know. Honestly,
All right, hold on.
that's just.
Okay, so once you get your two ordered pairs, it's going to be just like what we did on the other side. To find the limit of this function, you're going to average those y values. So again, we have the limit as x approaches 0 of our problem, our equation, the 1 plus x raised to the 1 over x. You're going to average those. So we're going to get the 2.7194123. You're going to add the 2.7171531 and divide it by 2. And so you find there that your limit is equal to 2.7182827. Now, these are close. They're not exactly the same because, again, they're both approximations, but they should be close to each other, and they are.